Today I am going to start the course on design of steel structure. Before going to introduce, first I will discuss about the syllabus, then some useful books and references, then some terminology which we used in case of steel design, and then some steel properties, advantages, disadvantages of steel structure, how we will do. Then lecture wise means module wise lecture contents. Okay. So, all these things I will discuss in today's lecture. Module wise syllabus I have made in this way. First module will be on introduction, which I am going to cover today, which will consist of properties of structural steel, IS rolled section means Indian standard rolled sections, IS specifications. Now, in module 2 I will cover on connections. Connection mean connections between two members, like say beam and column. When a load is coming from beam to column, it will come through, means the load will pass through that connection. So, connection should be designed in such a way that the load is passing without failure. So, connection is an important aspect on design of steel structure. In a industrial building or in a steel structure building, steel structure like bridge structure, we know different elements are there, different members are there, like beam, column, strut, splices, then column bases like base plate, gusset base, right, girders, many things are there, many members are there, but all these are connected one with another by some connections. So, before going to design element level means member level design, let us first know about the details of the connections, so that when we will be going to design of a beam or say column, how to design the connections also for that beam, that also will be able to know if we cover this first. That is why I am covering this module first. This module contains of say types of connections. Types of connections means we know riveted connection, bolted connection and welded connections are there, those connections. Then we will discuss about the riveted connections, then strength of the riveted connection, how to calculate the strength, how to calculate the efficiency and how to design a joint with riveted, right. So, with rivet how to design joint, those things we will discuss. Then we will go to advantages and disadvantages of welded joints. What are the advantages and what are the disadvantages of welded joints, those things we will discuss. Again, weld means two type of weld generally we use, one is fillet weld, another is butt weld, and then we will discuss about the bolted connections. So, broadly these things we will discuss on module 2 in several lectures we will make. Now, these are approximate, in fact some more or less means we will be going to add with this. So, I am not giving the exact one whatever I will be delivering the lecture, but a broad background I am giving. In module 3 I will discuss about eccentric connections. Eccentric connections means in module 2 the connections which are concentric means directly, say two members are there directly when we are going to join, say tension member or compression member, those things. But when load lying on the plane of the joint means when eccentricity will come into picture, then how to design, how to analyze the joint. So, with some assumptions, with some simplified assumptions we used to design those things through these eccentric connections. So, there we will discuss about say type of eccentric connections, then riveted and weld connections, then load lying in plane of joint, load lying perpendicular to the plane of joint, right. Then analysis and design of joint with sheet connections. with sheet, with bracket, how connections are made, those things also we will discuss. So, in eccentric connections I am repeating once again that we will discuss about types of eccentric connections, then rivet and weld connections. Then for rivet and weld connection we will see first load lying in plane of joint, when load is lying in plane of joint and when load is lying perpendicular to the plane of joint. So, in both the cases we will see how the connections are going to made by the use of weld, by the use of rivet. Then analysis and design of joint with sheet connections, with the use of sheet connection how to design a joint, that also we will see, right. This is the module 3. In module 4 we will come to the design of some member. This is first we will start with tension member. Tension member means when the members are under tension only. So, there we will cover say net sectional area. Why net sectional area will come? Because of rivet hole etc., the area will be going to reduce. So, we have to find out the net sectional area, which will be less than the gross area. Then permissible stress, how to find out permissible stress for different cases. The design of axially loaded tension member, design of member subjected to axial tension and bending. That means, first we will discuss about the design of axially loaded tension member, then means only axial load is there, then axial load along with bending, then how design will be changing, that will show. And to discuss all this, again we will discuss about design of gusset plates, lug angles and tension places, which will be required for design of tension members. These are some additional members which will be required for making joint. So, design of gusset plates, lug angles and tension places. So, those things also we will discuss, we will cover in this module 4. In module 5, we will discuss on compression members. Compression member means basically we used to sell say column, right. So, we will see modes of failure of a column means compression member, buckling failure, then effective length, how to find out effective length of a column, its slenderness ratio, we will find out, then design formula using IS code formula, means design formula what IS code has specified, those things we will see. Then design of compression member, right. Then eccentricity of load, if eccentricity of load come into picture, then we know that additional load will come due to eccentricity, means in terms of moment. So, that also has to be taken care. Then design of built up compression members. Built up compression members means when a single member, single roll section member is not sufficient to carry the whole compression load, then we may have to go for some built up sections. Okay. As per the requirement of the member, we may have to design the member in terms of built up members. Means built up members means we will show later that combination of 2 or more members, 2 or more roll section or some other type of plate section also, right. Then we will discuss about laced and battened columns, means when columns are built up, then we have to tie those through lacing or battening system. So, how to lacing has to be designed, in what way lacing parameters will be decided, in what way battening parameters will be decided, those things we will discuss, right. So, in compression member we will discuss mainly on mode of failure of a column, then buckling failure, effective length, slenderness ratio, design formula, IS code formula, design of compression member, eccentricity of load, design of built up compression members and lacing and battening of columns, right. So, those things we will discuss. In module 6, we will discuss about flexural members. Flexural members means beam. That means when the flexural action will come into picture. As we know, when member is under the transverse load, then bending moment will develop, right. So, because of bending moment, bending stress will develop. So, how to design against this bending stress, that we have to see, which is this bending stress in which member is developing. This is generally called beam member, right, or flexural member. So, we will discuss about the design procedure, and also we will discuss how to find out the allowable bending stress in compression and in tension, those things which will include in design procedure. Then built up sections, then plate thickness, how to decide, wave crippling, wave buckling, curtailment of flange plates, shear connectors, purlins. So, all those aspects we will be discussing in flexural members. I am repeating once again that design procedure of flexural member, which will include that how to calculate the allowable stress in bending, in compression and in tension, right. Then built up section, when the single rolled section is not able to carry the load, or when the span is very high, then we used to go for built up sections. So, how to choose the built up section, what way we will decide, all these things we will discuss there. Then plate thickness, how to find out, means additional plate thickness on the built up members, that we will be discussing. Generally, the I section is the most efficient section for carrying bending moment. For beam, we generally use I section. So, when I section is not sufficient, so the highest I section is not sufficient, then we used to provide plate in the flange additionally. So, that plate thickness and other details will be decided, and those things we will discuss. Then wave crippling, wave buckling, right, those things we will discuss. Then curtailment of flange plates, because the we will see, because the moment is varying throughout the span of the beam. So, we generally used to design the member in terms of maximum moment, but that maximum moment is generally happens in the mid span, and other places this moment is going to reduce. So, there we do not need that much heavier section. So, we can reduce the section by the use of curtailment of plates. The plates, additional plate, whatever we were using in the mid span where the maximum moment is developing, that we can reduce step by step towards the support. If the support is simply supported, that means moment is going to 0 at the simply support at end. So, those things, how to find out, all these things we will discuss in this module. Then shear connectors as another important aspect which we will discuss, and purlin etc., which we used in the shed, industrial shed. So, those things also we will discuss, where unsymmetrical bending will come into picture. Those things we will discuss there, right. Then we will go to module 7, where the gantry girder and plate girder will be covered. As you know, girder means it is a type of beam, girder itself is a beam. So, gantry girder and plate girder is nothing but a beam. So, we could include in the module 6, but we have intentionally kept in separate model, thinking that because gantry girder is a huge things, means many things has to be taken, means known. Again, plate girder is a separate chapter which we need lot of discussions. So, here I will give just some introduction to gantry girder and plate girder. In gantry girder, generally I will try to finish by 2 lectures. In one lecture the design procedure, in another lecture the workout example through which a gantry girder can be designed. But many other aspects, in many case to case for moving load, because gantry girder where we use, we know in industrial building, where the moving load means has to be lifted, some load has to be lifted from one place to other places through trolley or crab, that means load is going to move from one place to another place. So, there how to calculate the maximum bending moment and maximum shear force, then how to design, those things we will discuss, right. So, in fact, there are some codal aspects on design of gantry girder is also there, those things also we will discuss, like maximum deflection, permissible stresses, all these things has been given in the code, those things case to case we will discuss, right. So, in gantry girder we will discuss codal aspects on design criteria on gantry girder, then permissible stresses, then deflections, then design steps, then design component of plate girder. So, after this we will discuss about the design component of plate girders. Plate girder consisting of several components like wave, flange, then stiffeners. So, flange plates, many things are there, connections. So, all the design components we will discuss, and during that plate girder discussion we will include the self weight and economic depth, how to calculate for a plate girder, that we will discuss, self weight and economic depth. Then design of wave plate, right, wave stiffener, design of flanges, flange curtailments, design of bearing stiffeners, connections, all these things we will cover. And as we know, plate girder means again riveted plate girder and welded plate girder. Two type of plate girder we use in practice. One is riveted plate girder, another is welded plate girder. So, in both the cases design will be means to some extent similarity is there, again many differences are also there in terms of connections, in terms of finding the minimum depth, means economic depth, all these things are some differences there. So, we will discuss for riveted plate girder as well as for welded plate girder, but with very shortly, means maybe we will cover in 3 lectures. Okay. One lecture will be giving on design of riveted plate girders, design aspect of riveted plate girders, another lecture on design aspect of welded plate girders, and another lecture maybe we can go through and work out example of either riveted or welded plate girders, so that we have some idea, right. Then the last module will consist of column base, that is module 8, which will include slab base, gusseted base and grillage foundation. Column base means the load which are coming from the superstructure and coming through column has to disperse to the soil properly. So, the concentrated load coming from column has to be dispersed in some way, which we used to do through some plate which is called base plate, that is steel plate. First we provide some steel plate to disperse the load from column to the steel plate, then again we provide some concrete slab, right, concrete block to disperse load again from steel plate to the concrete block and then to soil. So, on the basis of type of soil and on the magnitude of the load and the type of load, whether only only concentric load or axial load or along with some eccentricity or some moment. So, on that basis we may have we have to decide whether we will go for slab base or gusseted base or glaze foundation. So, in which cases which is required, all these things will be learning through this module. So, these are the some module, means approximately I have divided to such modules, right. So, there will be 8 modules and 8 modules 40 lectures will be delivering to cover whole things. Now, as we know, the lecture is not sufficient, we have to go through some books and references, and of course, web courses, means in web also the lecture material will be given, through that also you can know. So, the books which I will suggest is, in fact, you can follow any book, but what I have followed I can give the name, that is Design of Steel Structure by P. Dayaratnam, right. So, this is one book which is very good and handy, which you can follow, Design of Steel Structures by P. Dayaratnam. Another book is Design of Steel Structure by L.S. Negi. It is very effective book, and the number of pages are very less in that book, but very informative and very effective, I should say, that efficiently it has been written. So, you can follow this also. Another book, Design of Steel Structures by S. Ramamurtham and R. Narayanan. This is Dhanpati Rai Publishing Company, right. So, Design of Steel Structure by Ramamurtham and Narayanan, right. Publishing company is Dhanpati Rai Publishing Company. This is also a good book, and in fact, lot of examples has been given and very details it has been written. So, one can use this book also. And L.S. Negi, the Design of Steel Structure by L.S. Negi, that was published by Tata McGraw-Hill, right. Remember Tata McGraw-Hill, and Design of Steel Structure by Dayaratnam, that is published by Wheeler. Okay. Another good book is that Design of Steel Structure by S.K. Duggal, which is also written in a very systematic way. In step by step design procedures have been given, which one can follow very easily. That is published by Tata McGraw-Hill. The book is written by S.K. Duggal, Design of Steel Structure, S.K. Duggal by Tata McGraw-Hill, right. Other books also you can follow, like Design of Steel Structure by Elias G. Abu Sabah, CBS Publishers and Distributors, right. So, this is also one another book which one can follow. Another book is Design of Steel Structure by E. H. Gallor and C. N. Gallor, J. E. Stallmeyer by McGraw-Hill, right. So, this book also one may follow. Another book which is also very good, means very complicated, means what you say, means very nicely it has been written and very detailed things are given, particularly in connections, etc. It has been given very nicely by S. S. Rai, that is Blackwell Science. This book also one can follow, but I will suggest this, means this 4 book as a textbook. Any one of the book can be used as a textbook, means you can use any of these 4, and these are the some references which also you can use for your knowledge, right. Now, the codes. Code means as we know from next lecture you need to follow code. So, please purchase code, have code, IS code before going to lesson second lecture, because without codal provision, means without code you may not be able to follow, right. This is must, this code, that is IS 800/1984, which will be the main code, that is Code of Practice for General Construction in Steel, IS 800/1984. So, here this is the main code which we used to follow, that is Design Practice for General Construction in Steel. Number we used to follow like this, IS 800/1984, right. This book is, means this code is must. Another code is must, that is this one, the Handbook for Structural Engineers, SP 6/1 1964. Here the steel properties of rolled section has been given. So, all the properties of the steel rolled section has been given, which can be found from this handbook SP 6/1 1964, right. Other code which will be required will be that Code of Practice for Design Loads other than earthquake for buildings and structure, that is IS 875 part 1 to part 5 1987. These codes will be required to calculate the load, different type of loads like dead load, how to calculate dead load, what are the specification, what are the density of different type of material. So, in part 1 it is given. Part 2 consists of live load, right. The different type of live load, what will be the live load at the terrace, what will be the live load at the mid floor, what will be the live load in residential building, and in commercial building. So, those things has been defined in IS 875 part 2. Similarly, in part 3 the wind load has been defined, right. How wind load is going to be calculated and in what city of our country, what will be the basic wind speed, all these things have been defined in this code. So, code IS 875 part 1 to 5 1987 is basically required for calculation of the load which will be coming to the structure, right. Then IRC code, some Indian Road Congress code will be required for vehicle load calculation. This is mainly required for bridge structures. Sometimes when we will be going for gantry girder design, the moving load is coming into picture. So, there we may need this code, codal references. Okay. So, and in case of plate girders also, plate girder, as we know, plate girder is generally used for long span. When the span of the beam becomes more than 18 or 20 meter, in that cases, and when the load is very high, then we use for plate girder, and this is generally used for bridge structures. So, there some codal provisions are there in Indian Road Congress code. So, those things will be required. However, I will suggest these two code immediately you should have for following my lectures, that is Code of Practice for General Construction in Steel IS 800 1984 and Handbook for Structural Engineers SP6 1 1964. Now, very shortly I will just discuss few things, like say what is the advantage of steel design, why we are going for steel design, why not the RCC design. Of course, both the design we have to know, RCC and steel design, both the design has their own advantages and disadvantages. So, when we are going to adapt some design, when we are going to follow some design, when we are going to build, construct some structure, we must know whether we will go for steel or concrete or steel concrete composite. So, we must know what are the advantages and disadvantages, so that the designer can choose, so that we can choose which one will be the favorable for us, right. So, what are the advantages? Just salient points I am giving. One is better quality control. In case of RCC structure, quality control may not be able to maintain up to our expectation, right, because concrete mix has to be done properly. Here as the we do not need, we can just simply purchase the particular grade of steel and we can use. So, we do not need to be worried about those. So, this better quality control can be made in the production. So, that can be a good advantage for steel design, means steel welding. Another is it is very light, it is light compared to concrete structures. So, dead load of the structure or the self weight, whatever we call, of the structure will be lighter, right. Another is faster to erect, we do not need to wait for curing of the concrete and for settling of the concrete cement, right. So, we can just simply erect, it is faster to erect. Then reduced site time, fast track construction. If we want to reduce the time for construction, then we can go for steel design. Large column free space and amenable for alteration. Now, as these are means as steel is very strong in nature and ductile, so generally column area become less. So, we will get free space, column free space, means in case of concrete building we will get means huge column area, right. So, we can make use of this free space, and also we can go for some alternation. Less material handling at site, that is also another advantages. Less percentage of floor area occupied by structural elements, because of lesser section required for the steel structure, we need less percentage of floor area occupied by the steel elements. It has better ductility and hence superior lateral load behavior, thus better earthquake resistance, right. as the steel has better ductility compared to concrete and other material. That is why we can say that it is a superior lateral load behavior, means lateral load behavior will be better and it will be a better earthquake resistance, right. So, in case of earthquake prone area we may think such type of building. Now, what are the disadvantages? Seeing the advantages, one can say okay, then we can go for the steel building, but why we are not going? Many things are there. The major thing is higher cost of construction, because this cost very high, this is the major thing. Another thing is skilled labor is required. We need skilled labor to erect and to make properly, to make the joint properly, to make the structure erect properly. So, we need skilled labor. Then maintenance cost is high, right, maintenance cost will be required high because of corrosion and other things. Poor fireproofing, as at 1000 degree Fahrenheit 65% and at 1600 degree Fahrenheit 15% of strength remains. So, this is another from fire proofing point of view, this is a big disadvantages, and electricity may be required sometimes to make the joint etc., for welding joint etc. So, that is, but majorly we should say that these two, high cost of construction and maintenance cost is high, right. So, from economic point of view we may not be able to judge if we go for steel building, but then should we not go for steel building? Yes, it depends what type of building we are going to do, and if we need more column area, means column free area, if we need more area and without column, then in that case we should go like in industrial building. And if it is a tall building, then we will see concrete for its own self weight, the area of column will become very high. So, we may not be able to go for high rise building. So, in that case steel building will be required, means steel structure will be required. So, we have to see both the cases and we have to optimize which will be better. Now, anatomy means what is the anatomy of a steel structure? There we will see one is called beam will come into picture, then column, then another is floor, bracing system which is very important for high rise cases, and then foundation and connections. So, these are the anatomy of a steel building: beams, columns, floors, bracing systems and foundation. Now, let us discuss some rolled section, right. Rolled section means, say I will come into details. Say one is say I section, which is generally used for beam member, means for beam, for flexural action we use for I section. Another is called channel section. So, this is called I section, this is called channel section, right, and this is called angle section. Okay, I will come details. This is called T section, right, and then maybe some circular round steel bar or with some rectangular steel plate, this also we used to make. So, this is solid, right. So, first let us discuss about the I sections. I section means how does it look and what are the things we have, let us discuss. First let us draw the section, how it looks. Right. This total depth of the I section is denoted in the code. Code means always SP6-1, that handbook, structural handbook, right. This is called depth of the section, H, it is denoted by H, and width of the flange is denoted by B, right, and this is called wave. Thickness of wave is denoted by TW, right. Another thing is thickness of flange, this is written as TF, and this is the x direction and this is y direction, right. And this TF, as you see, this thickness of flange is varying from here to here, right, it is varying. So, where we will measure? This is measure at a distance of b minus Tw by 4, b minus Tw by 4. All these things you will get details in SP 61, right. So, at this b minus Tw by 4, where b is the width of the flange and Tw is the width of the wave. So, b minus Tw by 4 at a distance of b minus Tw by 4 from end of the flange, the thickness whatever will come is called Tf, thickness of flange, right. And this is the slope of flange, this is termed as d. D is nothing but the slope of flange, slope of flange, and this is called R1, radius at root. R1 is nothing but radius at root, and this is R2, radius at toe, R2, right. So, these are the standard things which is given in the SP6 code, right. So, we have to know what are the terms, and accordingly the specification has been given, the value has been given, right. Now, let us see how the terms are coming. Like we used to say ISJB or JB. What is this? It is called Indian Standard Junior Beam. Indian Standard Junior Beam is denoted by ISJB. Similarly, Indian Standard Light Beam, that is denoted by LB, ISLB or LB. Similarly, Indian Standard Medium Weight Beam, ISMB, right. So, different type of I section beam, means I section is available, and mainly these are used for beam, that is why name has been given in this way. MB, medium weight beam, LB, light beam, JB, junior beam, Indian Standard Wide Flange Beam, WB, wide flange beam, Indian Standard Heavy Weight Beam, HB, ISHB or HB, right. Indian Standard Column Section, ISSC or SC, like this we used to use. Now, in table 1 of SP6 1, right, there it is given. You will see what are the things are given in table. First is given the weight. Suppose I am telling, say ISMB 550, then ISMB 550 in table 1 corresponding to ISMB 550 you will get several parameters details, like first you will get W, which is weight per meter in kg. So, ISMB 550, when you are telling, we know what is the weight of the beam, that is weight per meter in kg. Then you will get A is the sectional area. What is the area of the cross section of this ISMB 550, that is also given there, sectional area. Then H, that is depth of section. So, in case of ISMB 550, H will be 550 millimeter, right, H. Then B, width of flange, right. Then TF, thickness of flange. Then TW, thickness of wave. So, in this way all the details will be given there. Apart from this, so what are the things has been given? Weight, area, H, B, T, F, T, W. H, B, T, F, T, W means T, W is this, T, W, H is this one, the depth, B is the width of flange, T, F is the thickness of flange, that is given. So, all these things are given, along with this D, R1, R2, those things also are given. So, like Ixx, what is the Ixx value, Iyy value, then Rxx, radius of gyration about x direction, radius of gyration about y direction, then section modulus Zxx, section modulus in y direction, then R1, R2, D. R1, R2, as you know, R1 is the radius in root and R2 is the radius at toe, and D is the slope, right. Then, so these are the things we will be getting, right. Other things, as I told, this will be B, this will be H, right, this will be T W, this will be T F, right. So, all these things are given. Along with this, other things we will get, that is connection details, because as it is a rolled section, so some standard things are there which is given. So, through that we have to calculate, and these are all standard. Say for ISMB 550, the value has been given, like H1, you will see in connection detail H1, H2, I am coming which one is H1, then B1, C, G, G1, right, and also maximum size of rivet, right. So, all this you will get in a tabular form. What is H1 and H2? This will be the H2 and this will be the H1, right. And what is B1? B1 is from here to this is B1, right, and G is here you will get some rivet hole for riveting, etc. So, this is the gauge distance G, right. Then G1 is here also you will get some for connection. So, this is called G1, right. So, in this way we can find out all the details, right. So, if you go through the code, you will understand in details, right. Similarly, for say channel section, how does it look? For channel section, it will be like this, right. So, in channel section also, this is the depth of the channel which is written at H, this is called the slope D, this is the thickness of the wave T W, this is T F, thickness of the flange, right, and that will be at a distance of, it will be measured at a distance of B minus T W by 2, where B is the width of the flange, right, and this is as usual R1 and this is R2, right. So, the name how it is been defined, like different type of channel sections are there. Indian standard junior channel ISJC or JC, Indian standard light channel ISLC light channel, Indian standard medium weight channel ISMC medium weight, right, Indian standard parallel flange channel ISMCP or MCP, like this it is also given. So, in this way for channel section also we can find out, right. So, other things like Ixx, Iyy, Cyy, CYY means the CG distance, this is CYY it is told. CXX will be simply h by 2, so that is not given. CYY, then RXX, RYY, before that weight, area and other standard details, then the connection details, everything has been given, right. So I section, channel section, then we can see about the angle section. Angle section is denoted by Indian Standard Equal Angle, ISA, right, and in case of Indian Standard Unequal Angle also it is given ISA, but here say if, let me draw first, suppose this is a channel of equal section, right, sorry, angle of equal section, say this length is say suppose 20 mm, then the name will be like this, ISA 2020, right. And if it is unequal, that means if it is like this, say this, say like this, then say this is 40 and this is say suppose 60, right, then ISA 60 40, like this it is denoted. Again for ISA 2020, different type of thickness you will get. Thickness of channel means this thickness, thickness of wave, this is thickness, right. So this also you will get different, say you will get ISA 2020, say 6, 8, 10, say 60 40, say 6, 8, 10, 12, like this you will get, means with different thickness having same dimension in terms of its length, you will get different type of channel sections and their properties, right. So if we see the channel section, in fact it looks like this, say this can be denoted as ISA say 90 90 equal, and for unequal we can say ISA 90 say 60, something like this. And also you will see here properties will be little different, because the neutral axis will go through like this. So this will be the CG. So this distance is called CYY, not CXX. Along YY direction this will be CXX, remember, right. This is X and this is Y, right, and this distance is called A and this distance is called B, right, and other means neutral axis will be means about major axis, about minor axis, because this in this way also it can bend. So this is U and this is VV, right. So here you will get IXX, IYY, not only this, then IUU, IVV. So all the properties, and then area, weight, all these things you will get. So all this required property can be found, right. Another section we use is T section. Okay, we do not have much time, so I will not go into details, just I will show the T section, other sections I will not show. So say suppose T section, right. So in case of T section, this is the B width and this is thickness of flange, right, and this will be H, depth of the section, right, and in this way we can find out. And TF will be measured at a distance of B minus TW by 4. This is also B minus TW 5, this is also B minus TW by 4, and this is called R1 and this is called R2, right. And if neutral axis is here, then I can say this is as CXX. So these are the things in T section we will be getting, and the name we used to give as like this: Indian Standard Normal T bars, ISNT, Indian Standard Deep T bars, Indian standard light T bars, Indian standard medium T bars MT, right, ISMT, then Indian standard heavy T bar ISHT. So, heavy T bar means HT, medium T bar, light T bar, deep T bar, normal T bars, like this we use. Apart from this rolled section, other type of rolled steel bar sections we will get. So, this is the T section, Indian standard round section and Indian standard square section. This is another rolled steel tubes. Now, other type of steel rolled steel sheets are that we call Indian standard steel sheet section ISSH or SH. Another is Indian standard steel strip section ISST or ST. Now, some standard mechanical properties I will just write down here which is required, like we generally used to say yield stress. Yield stress in case of steel varies from 220 to 540 MPa. So, depending on the type of steel this will vary, right. Then ultimate strength, ultimate tensile strength will become 1.2 into Fy, if Fy is this yield stress, Fy is yield stress, then this will become ultimate tensile strength will become 1.2 Fy, right. Modulus of elasticity, modulus of elasticity, that will become 2 into 10 to the power 5 Newton per millimeter square, that will be generally considering, and shear modulus will be using shear modulus which is called G, that will be 0.4 into E, if E is the modulus of elasticity, right. And Poisson's ratio, that also is required sometimes to calculate different values, Poisson's ratio, right. For elastic range we will consider Poisson's ratio as 0.3, and for plastic range this is 0.5. Generally we use elastic range in case of steel design, so 0.3 we will use. So, this we have to remember, one is Poisson's ratio 0.3, modulus of elasticity 2 into 10 to the 5 Newton per millimeter square, this 2 is very important, and also shear modulus 0.4 into E, right. So, these are the mechanical properties we should know. Another thing is the stress strain curve for mild steel. As you know, the stress strain curve will become, just I am giving a small background because you know you have studied in strength of material. So, generally stress strain curve will become like this, no, right. So, here only thing I have to say is that, okay, this is stress and this is strain, only thing this is straight line, okay. Only thing I have to tell that we will be going for design of steel structure by working stress method. Still now in our country we are not following the ultimate load design method or limit state design method, right. So, for steel design we will be following working stress method, that means we will be following means the Hooke's law, that means strain versus strain varies with stress varies with strain, stress is proportional to strain, or stress by strain is equal to constant, that is E, E is equal to stress by strain. So, this condition we will be following, right. So, whatever design we will be following, that is working stress design method, remember this is we will be going to follow working stress design method, right. So, the mechanical properties now we have seen, we came to know that working stress design method will be using. Once again I am just giving an overview of lectures whatever I will be delivering. So, in module 1 which today I have discussed, that is introduction, where I have discussed about material and specification, structural steel and their properties. Properties means the mechanical properties, and that Hooke's law means elastic behavior only will be considering, those things I have told here, and the specification how has been made in IS code, those things I have discussed. Now, from tomorrow onwards the lecture modules will be like this. In module 2 there will be 6 lecture. In lecture 2 it will be different types of connections and their advantages, disadvantages. Different type of connection is say welded connection, bolted connection and riveted connections. Then in lecture 3 types of rivet joints, lecture 4 design of riveted joints for axially loaded members, lecture 5 welding, lecture 6 design of fillet and butt weld, lecture 7 bolted connections. So, these are the name of the lectures which I will be going to discuss, right. In next module, that means in module 3, we will be discussing again 6 lecture we will be spending for module 3, right, in eccentric connections. In lecture 8, it will be types of eccentric connection, and in lecture 9, design of eccentric connections with load lying in plane of joint for rivet and bolt, right. And in lecture 10, eccentric connection with load perpendicular to the plane of riveted joint. Lecture 11, analysis and design of joint with sheet connection. Lecture 12 will be eccentric connection with welded joint, and lecture 13 will consist load lying perpendicular to the plane of weld joint, right. So, these are the lecture I will develop, these are the title of the lecture. In module 4, there will be 4 lectures. Module 4 will be focused on tension members. In tension member, what are the things we will discuss? That in lecture 14 we will discuss strength calculation of tension members, right. Strength calculation of tension member, that means the net effective area, gross area of the tension member, net area of the tension member, deduction of area due to hole, all these things, efficiency, all these things we will discuss. In lecture 15 we will discuss design of tension member, what are the steps and how we will design. Then lecture 16, design of tension members, gusset plates, lug angles and tension places, means all these things we will discuss, gusset plate design, lug angles design and tension places design. And in lecture 17 we will discuss design of tension member subjected to axial and bending, right. Design of tension member subjected to axial and bending. In module 5 we will discuss about compression member, which is consisting of 8 lectures, right. In 18 we will discuss strength calculation of compression member, then 19 design of compression member, 20 design of eccentrically loaded compression member, 21 built up compression member, 22 design of built up compression member, 23 lacing for built up compression members, design of lacing systems, and 25 design of battened plates. So, all these things we will be covering in module 5. In module 6 we will be discussing about flexural members, where again 8 lectures we will be providing. One is introduction to the flexural members, beam, then design procedure of beam members, design of laterally supported beams, design of laterally unsupported beams, then we will go to built up members along with curtailment shear connectors, then design of built up beams, and then design of shear connectors and purlins. All these topics will be discussed here. And in module 7 we will discuss about gantry girder and plate girder. First we will go to introduction of gantry girder, then design of a gantry girder. Similarly, in case of plate girder, introduction to plate girder 1, introduction to plate girder 2, then design of a plate girder. And in module 8 we will discuss about column bases, which will be consisting 2 lectures, one is on slab base and gusseted base and another is on glaze footing. So, with these 40 lectures we will conclude. I hope you will purchase the code first, then you will listen to my second lecture, because unless we have the code we will not be able to follow the design classes. With this, I like to conclude today. Thank you very much for your patience for listening my lecture.